we are getting into is logarithms. We'll spend a couple days on this section, a couple days on the next section. And oh goodness, you all right there? So today we're just going to focus on what a logarithm is, how do we evaluate them, what are the properties we have with those logs. So first thing I have for you is a definition. I want you to write this down and then I'll talk about it. So a log and an exponential are very closely related. When you are looking at these, the base of the log is the same as the base of the exponential. Okay, so then if you are taking a log and turning it into exponential form, you basically go across the equal sign. So it's saying a to the y power equals x. If you have an exponential and you're turning it into a log, it's log base a of x equals y. So what a log is telling you is that exponent. When I say log base a of x, it means a to what power would equal x. Alright, so we will go back and forth between logs and exponentials. When we are talking about the domain, we know that in an exponential, if you take a number to a power, you're getting a positive answer, right? Positive number to a power gives you a positive. So the log, the argument here, always has to be greater than 0. And that will come into play more later on when we start solving equations with these. But in a log, both the base and the argument have to be positive numbers. The only place you could see a negative is what it's equal to. So first, we're just going to practice going back and forth between exponential and logarithmic form. No. Okay. So if I said 1.2 to the third power equals m, and I wanted to write this as a log, so you would say log, what is the base? 1.2. The base of the log and the base of the exponential are the same. When you're writing the base on a log, it is a subscript. So it's a small number down to the side. Then you go across the equal sign. So log base 1.2 of m, and it's equal to the exponent. So equals 3.
I remember this on my phone.
Good. Alright, so the next one. This is a log. If I wanted to write this in exponential form, we start with the base. So my base is e. Go across the equal sign. So it'd be e to the negative third power equals b. Okay, you guys can do C and D. So when you're looking at these, you just have to start with the base. So my base here is the 3. So it'd be 3 to the c power equals 5. You just draw in your arrows, they always make a circle. So this one, where's my base?
3.
So it'd be log base 3 of 9 equals 2. Alright, let's see if we can evaluate some logs.
We can't, not that's always beautiful. Really, it's fine.
Okay, I want the exact value of this. So there are 2 ways of doing it. Calculator is not involved though.
I'm just opening it.
So
There's a bird.
one way, if you understand what a log is telling you, you might be able to just look at this and tell me the answer. A log is giving you an exponent. So it's like saying 2 to what power would equal 16? 4. So our answer is 4. Okay? If you don't think of it that way, you could set it equal to x and use the definition. So it's 2 to the x power equals 16. Didn't we have questions like this on our test?
Yeah.
Yeah, we got a common base. So 2 to the x equals 2 to the fourth, and x equals 4. So if you struggle with just looking at it and writing out the answer, you can make it into an equation and use the definition to change it into exponential, and then it's just like the stuff we finished doing in the last few sections. So if I look at B, this says 3 to what power would equal 1 over 27? Alright. 2 to what power would equal 1? 0, because anything to the 0 power equals 1. Do you guys see how I'm just looking at these and getting the answer? So this one says 5 to what power equals 25?
Let's go.
Are those okay?
Yeah. Sorry, Owen was just trying to.
Did he succeed?
No, we didn't succeed.
That's the only one I messed up too.
Alright. Let's talk about solving some equations.
Not you, Frank.
Thank you.
Make a big deal.
Appreciate the clarification there.
Trying to
I'm
believe
bad,
it.
okay, I'm sorry.
Alright.
Or solve it.
How would I solve this?
You would,
Put it in the
take
not
over 4x minus 7 plus.
What about the log 3?
Get rid of,
Yeah,
put it in the other
change it
form.
into this.
Yeah. If we change this to exponential, that means 3 to the second power equals 4x minus 7. 3 to the second is
27.
9. We'll add our 7 over. Divide and we get x equals 4. Now, we do have to watch something on these. We need to check something with our answer. When we are dealing with these logs, the base and the argument both have to be positive numbers. So, just a quick check, if I plug in a 4, 4 times 4 minus 7, is that positive?
Yes.
Yes, so we're okay. If I had gotten 0, then that would have given me a negative 7, and my answer would be no solution. Okay, so you do need to watch that on these. B. So how would I write this?
2x equals 64. Like 2
X squared. Uh-oh.
Always start with the base.
That's dope.
So x to the
Must have got it
second
right.
equals 64.
We did
How do you get rid of the square?
Square root.
And when
Plus
you
and
add a
minus.
square root, you have to do plus and minus. So we get x equals positive and negative 8. But when we check,
Do we know solution?
is positive 8 okay?
Yes.
Yeah.
Is negative 8?
No.
No.
No. So our only answer is positive 8. Let's say I gave you
Oh, another one. Okay, right. LACUP.
what is this in exponential form? X to the negative 2 power equals 16 over 9. What does a negative 2 power flip it. So we have a couple options on how to work through that. Most of you, I think, just go ahead and write it like this, based off problems that we've done before with these. So then you get 16x squared equals 9. So x squared equals 9 over 16. So then what? Square root plus and minus. So plus and minus 3 over 4. Are both of those okay?
That is not what I did.
No, I didn't.
I
I just went ahead and
flipped
flipped
it.
it.
It's
Well,
very-
basically,
That's
we
another
just like
option.
did it without
You
all the extra.
could, like, just say I'm going to take each side to the -1 power.
Yeah,
That's what I did,
First.
and just-
Then it's x squared equals
Yeah,
9 over
yeah, that's what I
16.
did.
That's not what
And
I
that
did
works
either.
too.
That
That's
sounds
what
so
I did.
much simpler than
I
what I
Wrote
did.
down,
I
What'd you
just,
do?
I
I just flipped them.
it just had x,
If you
I had-
flip both sides, that's essentially
no,
what
I
this
had
is.
x to the -2 equals 16 over
Okay.
that, and I just flipped it.
Flip
I have 2 lines left.
Ah.
Yeah, that
I-
works.
4 things written down.
Yeah. Lots of different approaches to get to this solution.
Not even.
One thing I want to warn you, don't just automatically assume that only the positive answer works, because I could have very easily had said log base -x equals 16 over 9.
In the positive.
And then it would have been the -3/4. That would have been my solution. So you actually have to take the time to think about if I put this back in my problem, which ones will work. Let me give you guys a few to try.
You can try one. I think I can see. That's 16.
Yes. Okay.
Well done. Not bad.
So start with the base.
Yeah.
So 16 to the 3/4 equals x. So this means the 4th root of 16 cubed. And you should get 8.
Yes.
Next one, this means 36 to the x power equals the square root of 6. So this is like something you would have had on your last test, common base. 36 is 6 squared. A square root is what power? So we get 2x equals 1/2. So x is 1/4. Alright. Last one. This would be 2 to the 3rd power equals 2x plus 1. So 2 to the 3rd is 8. Subtract your 8. Divide by 2 and we get 7/2. And when you check, that does give you a positive argument. So
My
it's
bond
good.
doesn't work. We got to figure it out.
I think today's whole should just be this.
Like this stuff,
Is it? That's what it is. Is it?
most of it.
Well, that's
Okay.
the most. That means 90%.
Couple more things we need to talk about today. First of all, I just want to make sure you know how to use the log buttons on your calculator. There are 2 main log buttons.
Log and log natural.
There's the log and the natural log. So I just want to make sure you know how to plug these in. When I want you to do this, I will ask you to give me a decimal. When I ask you to do this, I will specify to use your calculator to get a decimal approximation. I'll typically have you go to 4 decimal places when you do that. So if I said log of 46, if you look above the on button, you go up, the 4th button up on that side is log, L-O-G. This is understood to be a log base 10. So we do log of 46. And if I said 4 decimals, we get 1.6628. The ln is called natural log. We'll talk more about that later. It's a log with a base of e. But for right now, if I just ask you to use your calculator, you want to make sure you use the LN button, which is right below the log button. A lot of times, not always, but a lot of times when you have these, it'll have an E with it. You're just putting all that into your calculator. So I'm just going to do 8 times E if you do second and the natural log button to the 6th power.
Uh-oh. Wait a minute.
I got 10 point.
Oh, wait, was that a multiplication sign?
Yes, so you do.
I put that.
Don't use the letter X, do a multiplication.
And don't use alpha E either. Alpha E,
Why would you do that?
that's what I did. That was just E.
Why would you do
And I
that?
put it to the 6th power and it
It
didn't work.
did not work.
Why would you do that?
Did he do,
Alright.
did he do
Does
zero?
everybody know how to put those in your calculator?
Yep, that worked.
Did he do zero?
No, it gave me an error.
Last thing today. I'll quit complaining. I'm going to have you write down some properties of logs. We'll do one slide with some examples of these, and then we'll pick up using these properties more tomorrow.
Yes.
Okay? So we're going to get them in our notes. I'm going to use just a couple of them and some examples today, and then we'll pick up there tomorrow.
Yes, he's gonna mess you up on the whole. What is that?
So write down these properties, and then I'll talk about them.
Talk about the whole.
So the first two properties. You guys ready? So the first two properties are really closely related to the fact that the log and the exponential are related to one another. We know we can go back and forth between the forms. If you think about exponential form, if I said like 2 to the 3rd times 2 to the 4th, when those are multiplied, what do you do with your exponents? Add them. So when you have the log of things multiplied, you add the individual logs. If I said 2 to the 3rd over 2 to the 4th. When things are divided, what do you do with your exponents? Subtract them. So if you have the log of things being divided, you subtract the logs. The power property is just something we can use for simplifying purposes. If you have the log of something to an exponent, it's actually equivalent if you just bring that exponent down in front as a coefficient. The bottom two. Alright, if we try to figure out why this works, let's say I said 3 to the log base 3 of 7 power. Okay? And if I were trying to figure out what that was equal to, if I said equals x, this is an exponential, right?
Wouldn't the M?
So if I am trying to change this exponential into a log, you would have log, the base of this exponential is the 3, so be log base 3 of x equals the exponent, log base 3 of 7. So what does x have to equal? 7. Okay, so that's what this property is telling us. What you can remember is a log and an exponential are kind of the opposites of each other. And so if the bases are the same, they would actually cancel each other out. And so it's just going to be equal to your argument. And it works in reverse as well. If I said log base 3 of 3 to the 7th power, and I wanted to know what that equals. Well, if I change it into exponential form, the base of this is 3. So say 3 to the x power equals 3 to the 7. So what's x equal? 7. So the log base a and a cancel each other, and it's just equal to that r. So these last two properties, they don't really have a name, but they're a shortcut you can use for simplifying some things. So this one, if I said I want you to evaluate 2 to the log base 2 of pi power, what would that equal? Look at your properties. What's this going to be the same as? Pi. The base of the exponential and the base of the log are identical, so they cancel each other, so this is just pi. base 0.2 of 0.2 to the negative 2 power, or negative
So,
square root of 2.
negative square root of 2.
Could you look at that and just be like, oh, this is the one that has 1 and the other two have 2, so that's like in the first one we have 2 2s.
As long as those bases are the same. Yep. So the base of the log and the base of the exponential are the same, so they drop each other out. All right. C. This is a little hard to read. I apologize for this. It says log base 4 of the cube root of 16. There's really a couple ways of doing this. Probably the most obvious one, you maybe wouldn't recognize a property right off the bat here, so what could you do instead? So the exponential form would be 4 to the x equals the cube root of 16. What's my common base? Okay, so a cube root is a 1/3 power. 16 is 4 squared. So you get 2/3. You could have used, if you originally changed the cube root of 16 to 4 to the 2/3 power,
Still go.
the log base 4 and the 4.
Oh, here.
All right, there is a handout posted on Classroom, and you've got the rest of the hour to work on that.
Miss, our